The force of electricity has always been held in high regard by humans. Electrical storms were terrifying to ancient peoples, to the point where Zeus, the Roman god of thunder and lightning, was the king of the Roman gods. Now, in our time, thanks to an inventor with a kite and a key, the power of electricity has been harnessed. Now, electricity is an essential part of life, powering our cars, heating our homes, keeping our houses lit, and charging millions of gadgets, large and small, that make life on planet Earth more convenient. However, the electricity we use is not harnessed straight out of the sky. Humanity has discovered how to create our own lightning, and the way we do this is through redox reactions. Couldn't think of a good picture to illustrate this slide, so I just have the reactions put up there. The top one is the main reaction. That's zinc reacting with the oxygen and hydrogen in the salt water mixture to form that zinc OH molecule and electrons, which can be used to power stuff. And the other four reactions are pretty much just supporting that one. You can see we're creating OH we're pretty much just creating OH in all of them, so that OH can react with the zinc. I never actually built this first prototype because as I was setting up some of the stuff with the lids and the electrodes, I realized that the electrodes wouldn't actually fit in the jars themselves because they were too small, and they would have been spillable, and no, it wasn't going to work. But onto the battery part of it. I used a zinc air battery, which means that the oxygen in the salt water inside one of these containers will react with the zinc, leaving the copper out of the equation entirely. Meanwhile, the zinc is producing free electrons with the oxygen. Forgot to take a picture of my second prototype. It was less spillable because it was still spillable, but less so because I had cut holes in the lids in the lids of these larger mason jars to allow the electrodes to slide in. I got 1.3 volts from 3 cells because the voltage was that low because the electrodes would brush up against the lid and it would lower the voltage level. And not a lot of the zinc electrode was exposed to the salt water, so we know the three rules for increasing a reaction. It works in reverse too. A reaction rate works in reverse too, so I wasn't getting much power out of my zinc electrode. So on prototype 3, I finally got the voltage where I wanted it, but it was heavy, really, really awkward to carry. It produced 2.41 volts. It could still be spilled, but I did electrical tape over those electrodes that they were not exposed to the lid. I also added some more of the water salt mixture to expose more of the zinc electrode to the salt water mixture so that I could get more voltage. I decided 2.41 volts was enough, so I started to move on to some other design flaws. I taped all the jars together to make them a little bit easier to carry. They were still really heavy though. And I caulked over the holes where the electrodes got inserted into the mixture. And the caulk does not mess with the reaction at all. It's still got the same amount of volts. And yeah. So this looks really simple, but it was actually kind of hard to do because the tape kept ripping and the yarn would fall out, and I had to tape the yarn together really, really ridiculously well to get it to stick to these two markers that I'm holding there. But it's portable. It's still a little bit heavy, but portable. You can't spill it, because the caulk is covering over the holes. 2.41 volts. The electrodes will not fall out of the solution. They're both caulked in, and the original holes were pretty tight to begin with. And that's about it.